Hello guys, it's me again. We are finally now at AC distribution, uh, but now we only gonna cover ring circuit for on in this video, right? So we have a question here again on our ETG notes. Let me show you. Good. Um, we have a circuit there, and it is like this. The figure below represents a single line diagram of a two-core AC ring distribution system. Calculate the current distribution of the system, calculate the voltage at each load point. Then they gave you the circuit. Sometimes you might have to draw the circuit yourself. But you just, oh, that's 28 marks, by the way. That's 28 marks. Yeah, so we're gonna do that today. Very tired. Okay, cool. So let me pause the video and then just draw the circuit. No? We are now, I think, yeah. So this is what they gave you, or this is what you have. From there you have the resistance here, 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 and here. I'm not gonna label those. You know, right? You have the circuit with you. I forgot to label. That's A, B, C, and then you have D. Okay, cool. So the first step that you're gonna have to do is to give our currents direction, right? On AC, remember with DC it would make something like a closed loop. Current will travel from AB, through AB and then BC, CD, going back to DA, right? This time the story is a bit different. You assume that current travels from the supply all the way to your right? Meaning you're gonna have an arrow there, you're gonna have an arrow there, you're gonna have an arrow, two arrows entering bus bar C, like that, right? Cool. That's the first thing that you do. Now the second thing that you do, you remove any interconnector. Okay, there are two connections. How do you choose an, not interconnector, I'm sorry, a distributor? Now how do you choose which one to remove out of the four distributors? You choose the furthest one from the supply, right? Meaning on this circuit we have BC and then we have DC, right? So we're just gonna choose one. They chose BC on the slides, if I'm not mistaken. Let me go there. Oh, they chose DC. So again, remember, I want to make you understand your notes, so I'm going to remove what they removed. And on your own, somewhere during your free time, please remove BC just to see if you really understand what you were doing, right? Sharp. So I'm gonna remove this and then replace it with dotted lines, just to remind us that we had something there. Okay, now that's really dotted. Make it a chain line. Then we have that arrow entering the bus bar. Cool, we have something like that. Nah? After removing that, the first thing we gonna do is to take advantage of the series current. Bro, what do you mean? I'll show you what I mean. Let's talk about bus bar D. Remember said you have to see a bus bar just as a node in a circuit, right? Interconnector AD comes entering the node. That's AD. It enters the node, and then D simply leaves the node. ID simply leaves the node, right? This is current. This simply means that this current is equal to this current. You see, this is series connection. I know you can see that. So delete. So now we're going to take advantage of our series currents, meaning our ID. Okay, let me start with unknown. Our ID DA is equal to ID, that is 48 comma what is it? Oh no, it's just 48. I'm sorry, with an angle of 54. I'm looking at the slide. 54,97. Right. Okay. It's important to note that that is not the actual current, or is not the real current. It's just, it's our route to the right direction. It's just, yeah, right. So again, we're going to look at bus bar C. You see, at bus bar C, you have IC leaving the node, correct? And then you have IBC entering the node, meaning again you have series connection. So those are in series. That simply means they are equal, right? Cool. So IC, what is it? Okay, IBC is equals to IC, and that is 54 at an angle of minus 60, right? So looking at bus bar D, I mean not D, B, this is now bus bar B. You have current IAB entering the node, and then current BC leaving the node, current B leaving the node, meaning AB is equals to B plus BC, Kirchhoff's current law, right? Yeah, I know you saw that. We've been doing this thing for as far as I can remember. So yeah, I said IAB is equals to IBC plus IB. Now your IBC is 54. That's 54 at an angle of minus 60, plus your IB is 36 at an angle of negative 48,01. Right. So okay, let me go step by step. I want to save time, because library there will be noise in here, and I won't be able to continue with the record. But let's go. That's 27 minus J 46, 765, right? And then you have now plus, like, taking out 36 minus 48,0. You have 24,084. That's 8. And minus J 26,757. Adding those together, you should get, I think I should not consult my book to save time. Where am I? That's IAB. I'm sorry. Okay. Yeah. So your real part should be 51,084, and then your imaginary part is minus J 73,522. You just punch that thing in your calculator. You have real plus real, and then you have imaginary plus imaginary, and they're both negative. I know you saw that. So we get that, right? Converting it to polar. Converting it to polar, you get 89,527 at an angle of minus 55,21. That's IAB. So I'm gonna remove all this mess and then just put the final value, right? Delete. Then take you, put you up there. Cool. we have those. Right? I can't see my phone. Oh, I know. Hey man. Uh-huh. So what we have to do now that we have oh, I think I told you that these are not the actual currents. These are just, we just working, or we're making this thing simple to work with. We're gonna need this, right? Now step number 2 is to find the voltages, the voltage of each section. When I say section, I mean the top section and the bottom section. Top section is VAC. Like if you were to put your bulb at an open circuit, look, remember what I said about Thevenin? I said you remove the component that you're actually interested in, right? That's what we removed. And then now you're gonna put your probes there. So what you're looking for this voltage. You see, we're looking for the voltage, voltage DC. Yeah, but the reason why we have to go all the way and calculate the top and the bottom voltage, let me show you why. You see the arrow from A to B, meaning voltage AB goes into that direction, voltage BC goes into that direction, but voltage AD goes in an opposite direction. That simply means VAB, okay, I think I should put it that way. VAB plus VBC minus VAD all equals to 0. Kirchhoff's voltage law. You see it, don't you? In case you didn't see it, VAB is going it is taking a clockwise motion, right, or rotation, and then VBC is also in clockwise, meaning you can add them together. But VAD, now it opposes those. You see? Yeah, that's why we came up with this formula. This one. Cool. So now we're gonna substitute our values. Remember the currents that we got. VAB is simply IAB, RAB, and then you're gonna add it with IBC, RBC. Then you subtract IAD, RAD. You result them to 0. Okay, I think I should do this. I think I should work up there, not here. Let me check my stuff. Yeah, okay, copy, paste. I'm gonna paste it just below. What happened with VAC? What is this thing for? I don't know, so I'm just gonna remove it. Delete, paste. Good. So this is very simple. We're gonna take the value of AB, which is 89. Oh, 89,527 angle of minus 5521, and then we couple it with the resistance value. The resistance was given to us is 0,36 at an angle of 18. Remember the picture that I just showed you, or the circuit that I just showed you via the camera of the phone? Yeah. So I'm not gonna do that thing on the video. I'm just gonna pause this and come up with the final answer. So I decided to keep consistency. Remember from the previous videos, there was somewhere where I calculated V top as well as V bottom. So I decided to keep that, or to rather take that route, of which is going to give you the same thing, right? Anyway, from this point, I got, oh, well, I just entered, the thing is the, what you call, I just substituted values there, right? The value of AB, of BC, as well as the resistances and everything, right? You should get your V top as something like that. Okay, let me do this. Put a bit down there. You should get your V top as, I remember I did this thing. Oh, by the way, your V top is equals to VAD. Let me show you what I mean. The top section of this circuit is from A to D. You see? That's the V top. That's why, I mean, not D, C. I'm sorry. What did I say? C. C. So that will give you 54,783 at an angle of negative 40,43 volts. And then now looking at the circuit again, meaning your V bottom is just from A to D. You see? Good. So your shop. Your V bottom, which is also known as VAD, is equals to, now you should get your VAD as 17,96 at an angle of 74, yeah, 74,97 degrees, and this is also in volts, right? Cool. So our next step is to find the VThevenin. VThevenin, which is also VDC, is equals to the difference between the two current, between the two voltages. Why is it the difference? Because the other two, or the top section, is going in is, let me say, is rotating clockwise. Just to make this thing is, let me just say, is rotating clockwise, and then VAD is which is the bottom current, is rotating anti-clockwise. That's what's the difference, right? So it's just VAD AC minus VAD. You substitute your values there, you now have them, right? And then they should give you your VThevenin as 61,467 at an angle of minus 51,41 volts. Now you have your VThevenin. By the way, remember what we were taught from I think it's S2 or something, diploma. We were told that when you're doing Thevenin, remember you remove your component, the one that you're interested in, right? That's where you're gonna play. Right now, what we just did to find the VThevenin, we basically put our voltmeter there to find the voltage across those 2 points. So now what we're gonna do on the same 2 points, now we're gonna place our ohmmeter to find the resistance. And you see the resistance is nothing but AB plus BC plus A plus DA. I mean, it's the resistance. There's no way you're gonna have minus DA, right? Cool. So I don't feel like writing it down because I want to keep the video short, and then I also feel like I have limited time in here. I have to leave. So Z Thevenin is simply ZAB plus ZBC plus ZAD. They gave you values. You will not struggle getting this. You should get your Z Thevenin as 1,049 at an angle of 0.17,3 degrees, and that is in ohms. Remember the circuit. Just follow the circuit. Do calculations looking at the circuit, right? I'm looking at my calculations now on my book. I did this thing, so I'm just copying on my phone. At this time, I'm explaining it, unlike just someone showing you a picture without having to explain anything. Cool. So now we have our Z Thevenin, right? Should I create a page? Okay. Our I Thevenin. Remember I said after now we are done calculating. Come on. After we're done calculating V Thevenin as well as Z Thevenin, now we look for I Thevenin, which is now V Thevenin all over Z Thevenin plus, now we bring back our component, and it had a resistance of 0.39 at an angle of 15 degrees. Again, you substitute the value of V Thevenin, you substitute the value of Z Thevenin. Or should I do it? Okay, let's go. Well, it's gonna take too long though. Copy. Paste. Cool. And then your Z Thevenin is 1 comma something. There it is. I'm gonna also kidnap it as it is. Copy. You go there. And we paste it here. Paste. Oh no. I'm sorry. Is the video running? Yeah, still running. Yeah, 22 already. We're gonna add that with now our what do you call this, distributor resistance, that is 0.39 at an angle of 15 degrees. My 5 always has problems. Okay, cool. So I'm not gonna repeat the voltage or the numerator. I'm now gonna sort the denominator. V Thevenin, converting it to rectangular, Z Thevenin, I'm sorry, is 1,002 and plus 0,312. You have J there, right? You're gonna add it with, let's see, now we have the regular 0,39 at an angle of 15. That will give you 0,377 plus J what? 0,101. Now, adding those together, we still have our numerator as it is. Let me see if I can take it real fast. Copy. Cool. Actually, waste no time. Just put it there. And then you have equal sign. We're also gonna put it somewhere there. Good. I'm gonna have a line. So adding 1,002 plus we're adding it with 0,377. Hypo. We have the real part as 1,379. and then plus. Now go for the imaginary plus 0,101. You have your J as 0,413, right? Remember, your voltage is still as it is. Paste all over. Now we're going to convert that to polar, right? Polar of point answer. And then you have your magnitude as 1,44 at an angle of 16,673, right? Now you divide the two magnitudes. That's 61,467 divided by 1,44. You get a magnitude as 42. That's the I-Thevenin. Oh, hi man. I'm sorry. That's 42,685. It says on my calculator at an angle of, now we have minus 51,41 minus 16,673 at an angle of minus 68,083. Now this is in amps, right? So now we have the I-Thevenin, which is also known as IDC. So that's the actual IDC value. Is not the clone or those that I said they're just the root or the steps. I mean this current. The I-Thevenin that we just found has got nothing to do with this. By the way, I said these are just temporary currents. So now we can calculate our actual currents, right? Using the one current that we just got, which is IDC. I don't feel like I'm presenting good today. I think it's because I'm tired, but it's okay. I know you understand me, right? So I'm gonna create space and then cut all of that. Put it up there. Cool. So we now decided to put back our distributor. Yeah. We decided to put our distributor and already got the current there, right? So at bus bar C, we're focusing at bus bar C. Current BC plus current DC is equal to current IC, Kirchhoff's current law. So I'm just gonna say IBC is equal to IC minus IDC. You see it here. Good. Good. So that's what I'm gonna do. IBC is equals to IC minus IDC, and we have our IC as 54,60. I mean at an angle of negative 60. I'm sorry. At least I said the wrong thing, but then I wrote the right thing. Yeah. Minus that current that we just got there. What happened to our current? Something happened. This is too much. This is just too much. Yeah, I knew something happened. It's okay. I'm sorry. Sharp. I will repeat. I don't mind. I said IBC is equals to IC minus IDC. Now we have IC as 54 at an angle of negative 60. Now we're gonna subtract the value that you just got there. I'm gonna take this, copy, paste it where it should be. Should be there, a bit small. Good, right? So convert them to to rectangular, rect 54 minus 60, you have 27 minus j 46 comma 765. Now we're gonna subtract. Now we have rect of 42,685 negative 68,083. Now we're subtracting 15,933 minus j. What's your j? Your j is 39,6 in bracket. That minus is gonna make it minus 15. That minus is gonna make it plus 39, right? That's why I have the brackets. So now 27 minus 15,933, you get your real value as 11,067. Now let's look at the imaginary. That's minus 46,765 plus 39,6 is minus j 7,165. Let's convert that to polar and then confirm with the slides. That's Paul pre-answer answer. We have 13,184 at an angle of minus 32,92. It's in amps. That's your IBC. We have IDC, we have IBC. So going back to bus, now let's go to, okay, we found this. Oh, remember I drew something there. I did this, I put it back with a different color. Sharp. We got this. Now we can find this and then this. Let's go for AB. AB is entering point B, and then IB and then IBC, they're leaving the very same point. So meaning Kirchhoff's current law. Okay, let me first create space. I hope you wrote that down. Just want to keep final values. Put it there. Now you have this as IBC. Cool. Now our IAB is equals to IB plus IBC, which I saw why, right? So our IB, I think, is 36 at an angle of negative 48,01 plus, let me paste it, I'll make it small. Good. Now convert it to polar, no, rectangular, I'm sorry, rectangular of minus 48,0. Oh no, let me pause the video. Good. So what I did, I converted our values in rectangular, both of them, right? Then added the like terms, meaning real with the real, and then imaginary with the imaginary to give me the imaginary there. Good. And I got my thingy, my current AB, and then convert it to polar. You always want to keep your stuff in polar. Apparently, I can't say always, because in the memos and everywhere else, they mark the polar. So please just take them to polar, just in case, just be safe. Have both polar as well as rectangular. That's, let me remove you and then take you, put you there, and then remove this. Cool. So now we have IAB, IBC, and IDC. We are left with one, which is IDA. It is at bus bar D. Is at bus bar D. So at bus bar D, we have DA entering the bar, and then D leaving the bar, and then IDC leaving the bar. That means that this is equal to sum of this, right? Cool. I'm gonna go ahead and do it. Okay, I'm not gonna erase that, because you will excuse me, I'm very tired. So I think ID is equals, I'm sorry, is equals to, I said the sum of ID plus DC. Good. So your value for ID is, where is it, 48 at an angle of 54.97 plus, and then now you're gonna have your IDC. What is DC? There is DC. Your IDC there. You copy that. And make a beautiful pass. I knew it. Hi. What is the 4? Hey, these things. Yeah, no, they will disappoint you in front of Pamkwan Baban. I'm gonna take you again, copy, now paste it there. Good. Now you have that, right? Convert both to rectangular. You will find your IAD as something close to, if not 42, no, 43, I'm sorry, 43,48 at an angle of minus 0,44. So this is your IAD. Sharp. I think this is where I'm gonna stop. So the question actually didn't ask for the current. Did they ask for the current? Let me go back. I'm going back. Where is it? Well, okay, it wanted the current. Yes, there was number A, and number B, it wants the voltage at each load point. So I'm just gonna show you at point B. At point B, we have VB is equals to VA minus the voltage drop AB. You have current AB, you have resistance AB, you can find that. You also have your VA as 480, right? Cool. At point C, VC is simply VB minus the voltage drop BC. Good. And then your last voltage is VD, which is gonna be VB minus, no, not VB, I'm sorry, VC minus VCD. Then you get your volts. That's it. You'll confirm your answers. You should get the same thing they got on the slides. I did this thing, and I can say, I can proudly or confidently say that the slides, the right. Yeah, the right, because other people did this thing, and then whether they got the corresponding values. So yeah, that's it for this video. I'm only left with now ring, not ring, AC interconnected. I don't know. I think I'll do it tonight. Yeah.